Morning students. So today we are going to study area of plane figures. Okay. So let us move to the smart board. So first of all we will see the area of a plane figure in which area of different polygons are given. So for this we will see a short video related to the area
Let's
of
go to this
quadrilateral.
quick visual representation of classifying quadrilaterals before getting into the derivation of the formula for the area of each. Recall that a polygon is a closed figure made up of at least 3 sides. A polygon with only 4 sides is called a quadrilateral. Let's look at some special quadrilaterals. If the opposite sides of a quadrilateral are equal and parallel, we call it a parallelogram. A quadrilateral with only one pair of parallel sides is called a trapezium. A parallelogram can further be classified into a rhombus and a rectangle. A parallelogram with all 4 equal sides is a rhombus. A parallelogram in which all the angles are 90 degrees is a rectangle. Let's now look at a square. A square fits the definition of a rectangle as well as a rhombus. In a square, all the angles are 90 degrees and all 4 sides are equal. Now that we have been through the classification of quadrilaterals, let us look at deriving the formula for the area of each. Through the rest of this animation, we will look at deriving the formula for a polygon, a general quadrilateral, a trapezium, and a rhombus. You can view areas of a parallelogram, a rectangle, and a square by rolling the mouse over the figures.
Okay. So we know that what is the polygon? Tell anyone polygon. What do we mean by polygon?
A closed figure has 5 sides.
A closed figure made up of line segments, not 5-sided. 5-sided will become means it is a pentagon. So under polygon, quadrilateral is coming that have a 4 sides. Now quadrilateral is divided into 2 types. One parallelogram in which 2 pair of opposite sides are parallel and equal, and one trapezium in which only 1 pair of sides are opposite sides are parallel and other opposite sides are non-parallel. Now further parallelogram is divided into 3 categories. Rhombus whose all sides are equal, square also all sides are equal, but one additional property that in square all the angles are 90 degrees. Rectangle opposite sides are equal and all angles are 90 degrees. Okay, na? So now one by one we will see how to find the area of any quadrilateral, either it is general quadrilateral or special quadrilateral. So first of all we will move to find the area of the polygon first. Okay.
The area of a polygon can be found by dividing the figure into its constituent triangles. This process of finding the area of a polygon by dividing it up into its constituent triangles is known as triangulation. To do this, we must pick any vertex and then draw diagonals from that vertex to all non-adjacent vertices. Since the given polygon has 5 sides, we can divide it into 3 triangles. Therefore, area of the polygon is equal to sum of the areas of triangle 1, triangle 2, and triangle 3. We know that the area of a triangle is equal to half base times height. Substituting the values for base and height of each triangle, we get the area of the polygon.
So in front of our we will see that there is a pentagon. So now for the polygons, for finding the area, we have one option to divide into a smaller triangle, and this method is known as triangulation method. As we are dividing the polygon into small triangles and finding the area of that triangles, that method is known as the triangulation method. So now, if here you will see, this is a pentagon. How many sides pentagon have? 5 sides. Now the question coming that sir, in how many triangles a pentagon is going to be divided? This is the question. Okay, let it be, it is divided here into 3 triangles, but how we will know that in how many parts we will divide a pentagon? Okay. So general, keep in mind, I will tell you, for any polygon, suppose it has n side, polygon I am telling. So polygon, you know how many sides required to make one polygon. The smallest polygon also, if you will make, how many sides we need? The smallest polygon, 3 sides. Very good. 3 sides a triangle. Now what I told, to find the area we need to divide it into triangles. So always keep in mind that how many triangles we will divide, that is n minus 2. N minus 2 triangles. See, in the case of triangle, what is n? In case of triangle, what is n? 3. So 3 minus 2, 1 triangle. So in triangle, 1 triangle is always there. Suppose I have a quadrilateral. How many sides n? 4. So maximum we will divide it into 2 triangles. Same pentagon, how many triangles? Hexagon, 4. So this we can use n minus 2 triangles. Understood? Now,
Pentagon have 4 no sir.
5 sides, sir.
4. Yes.
What 4?
Hexagon.
Hexagon 4, huh? Pentagon 3, hexagon 4. Okay? So now this pentagon is divided into 3 triangles. And now we can easily know the area of triangle. That is, what is the area of triangle? You all know?
Half into
Half into base into height. So it is very easy to find the area of the triangles for us. So see, here it is the area of triangle PTQ. Having the base, what is the base of this triangle? The base is a PQ and the height is a H1. Now, similarly for the area of triangle QRS, base is a QS and height is a H3. And for the triangle TQS, base is what? QT and height is the H2. So when we will add the area of all these 3 triangles, we will get the area of the required polygon or pentagon. Okay then? So now we will move further. And we will see
Area
how
of the
to
general
find
quadrilateral
the area of
will be
the
found
general
by
quadrilateral.
triangulation. Triangulation of a quadrilateral will give us 2 triangles. The area of a general quadrilateral is therefore equal to the sum of the area of triangle 1 and the area of triangle 2. We know that the area of a triangle can be calculated using the formula half base times height. Hence, the area of triangle 1 is equal to half base QS times height H1. Similarly, area of triangle 2 is equal to half base QS times height h 2. Adding the areas of triangle 1 and triangle 2 will give us the area of the quadrilateral. Since QS represents the diagonal of the given quadrilateral, we replace QS with D. The area of a general quadrilateral is therefore half times the diagonal multiplied with the sum of the heights for the two triangles.
So now, in the case of quadrilateral, as I told you that we will divide any polygon into triangle first. So it has four sides. Means again we will substitute that formula n minus 2, means we will divide the quadrilateral into two triangles and we will find the area of that two triangles, and at last when we will add the area of that two triangles we will get the area of the quadrilateral. Okay, basically we have to take any one of the diagonal of the quadrilateral, any one diagonal, as it is taken here. Which diagonal? See, diagonal QS. Okay, and on that diagonal from opposite two vertices heights are there, one h1, one h2. Okay, so that's why we can say that area of the general quadrilateral is half into d into h1 plus h2, as it has both the triangles have a common base, that is QS, or also the diagonal for the quadrilateral PQRS. Okay. Next, we will see how to find the area of a trapezium.
To calculate the area of the trapezium, we divide the figure into a rectangle and two triangles. Let A and B be the lengths of the parallel sides and h be the height of the trapezium, and hence the height of the two triangles. The two triangles can be merged to become triangle 1 with base B minus A. Therefore, area of trapezium is equal to sum of area of triangle 1 and area of rectangle 2. Let's call this equation 1. Now, area of the triangle 1 is equal to half base times height. Substituting the values for base and height, we get area of triangle 1. Next, area of rectangle 2 is length times breadth, which is equal to A times H. Let us now substitute the values of the area of triangle 1 and the area of rectangle 2 in equation 1. On simplifying, we get h divided by 2 times the sum of b and a. Therefore, area of trapezium is equal to product of perpendicular distance between the two parallel sides and half the sum of the parallel sides.
So now, in case of trapezium, we will not only divide it into the triangles. What we will do, we will divide it into two small triangles, which will constitute one big triangle. Okay, this is one small triangle, suppose, and this is one small triangle, and the middle part is the rectangle. Okay, now these two parts will form one triangle. Okay, see, this from this here to here, it is what given? It is A. So when we will add these two parts, what we will get? B minus A. Overall it is B. Okay, and here to here it is A. So the remaining portion will be B minus A, which will act as the base of a triangle, and the height of the triangle is given already, that is h. So area of the triangle will become half into B minus A into h, whereas rectangle having height what? Length what? H, and breadth what? A. So its area will be A into h. So we will get the area of the trapezium as perpendicular distance into sum of two parallel sides divided by 2. Okay?
Rhombus, sir.
Triangulation of the rhombus will result in two constituent triangles. The area of a rhombus is equal to sum of the area of triangle 1 and the area of the triangle 2. Let's call this equation 1. For calculating the area for the rhombus, let us first find the area of the triangle 1. Area of triangle 1 is equal to half multiplied by the product of QT and PO. Likewise, area of triangle 2 is half multiplied by the product of QT and RO. Let us now substitute the values in equation 1. Half QT is the common factor, and the sum of PO and RO is equal to PR. Therefore, we get area of the rhombus is equal to half QT times PR. We can also say area of rhombus is equal to half times product of two diagonals, since QT and PR form the diagonals of the rhombus.
Sir, in that we have
So-
4 now, sir.
What?
Triangles 4 now, sir.
Small triangles 4, if you will see the big one, PTQ, one big triangle, and RTQ, one another triangle. Okay? So it is same like the general quadrilateral. In general quadrilateral also we are dividing the given quadrilateral into two triangles and finding the area of individual triangle and adding it. But the case is here what? That the height of the individual triangles are acting as a diagonal of this rhombus. Okay na? That is OP and OR. As we know that diagonals of a rhombus are perpendicular bisector. And perpendicular distance is always known as the height in a triangle. So that's why the area of the rhombus is half into product of the diagonals. Okay na? So now we will move to the
Sir,
quiz and we will try to solve some questions. Okay?
sir, we can take the 4
What?
triangles.
This is small four triangles. Again, you have to divide it in the height. You have to give it. Height is not given. Now, suppose this triangle I will take POT. How we will find its height? That's why we will divide into two triangles only. Okay? The length of diagonal PR of quadrilateral PQRS is 16 cm as shown. The height of triangle PQR and PSR are 5 cm and 6 cm respectively. Find the area of quadrilateral PQRS. I will just little zoom it. This is the figure. This is the our quadrilateral. Okay. What is the area of the quadrilateral? Area.
88 centimeters square.
88 centimeters square. We will see is it correct or not. Very good. Clap for this. See, if you will see the figure, it has a common base. Common base, that is PR. PR having the common base, that is equals to 16 centimeter. Okay, and the value of H1 height one, we will take any, either 5 centimeter or 6 centimeter. So h1 is 5 centimeter suppose, and h2 is how much? 6 centimeter. So you know very well the area of the general quadrilateral, what it is? Half into d into h1 plus. Now if you will substitute here, half d is how much? 16, and h1 plus h2, 5 plus 6, how much coming there? 11. Now 2 eliminate 16 8 times. Now 11 into 8, 88 centimeters. Understood all of you? Okay. Now we will move to the next question. Okay, this leave it. Next one. The perimeter of a circle is equal to the perimeter of a square of side 22 centimeter. Find the area of a circle. The perimeter of circle is equal to the perimeter of square of side 22 centimeter. Find the area of the circle. Anyone?
Option D.
Option D, 616 centimeters square. Very good. Clap for Vishnu. Sit up. Now if you will see here, the perimeter of circle is equal to the perimeter of square of side 22 centimeter. Just tell me the question, okay? We will move to the whiteboard first. Perimeter of circle. Perimeter of circle is equal to perimeter of square whose side is 22 centimeter. So what is the perimeter of square? Perimeter of square 4 into side, 4 into 8. Very good. So perimeter of circle means 4 into 22 centimeter, because perimeter of circle is equal to the perimeter of the square whose side is 22 centimeter. Now perimeter of the circle means what? Anyone? Perimeter of the circle means what? Circumference of the circle. Very good. And what is the circumference of the circle?
2 pi r.
2 pi r. Very good. So we will write it 2 pi r is equal to 4 into 22. 88. Now if I will see here, 2 into 22 by 7 into r equals to what I get? 88. R equals to 88 into 7 by 2 into 22. 22 will cut 88 4 times, and 2 will cut 4 2 times. So what we will get the value of radius? 14 centimeter. Now we have to find the area of the circle. So area of the circle is how much? Area of circle? Area of circle is pi r square. So 22 by 7 into 14 into 14. 7 will cut 14 2 times. We will get 22, and 14 2 is 28. So 28, 2 into 28 gives us 616 centimeters. So area of that circle is 616 centimeters. Okay. Now we will move to our class again. We will see the question. Next question. This we completed, na? Right off, yeah. Now a sheet is in the shape of a trapezium. One sheet, paper sheet is there, which is in the shape of a trapezium as shown in the given figure. And we have to find the cost of painting that sheet on both sides, given that cost of painting is rupees 30 per meter square. Just you tell me what will be the answer and how we will find the answer.
So the answer
Answer C.
C. Correct answer. So what we will do, Akshara, tell me how we will get the answer. First of all, what we have to do? First of all, what we have to find?
We have to find the area.
First of all, we have to find the area. As we got the area, then what we will do?
Perimeter total.
Perimeter no need. The area we got. So after that, what we will do? We will multiply the area with the rate. 30 per meter square rate is given. We will multiply the area with the rate. We will get the cost. Okay, na? So what is the area of the trapezium? Area of trapezium what? Half into sum of parallel sides. Parallel sides are 10 plus 20, 30 into distance between them, that is 15. Now 2 will cut 30, 15 times 15 into 15, 225 meter square. Area of the trapezium 225 meter square. Sit down, sit down. Now the cost of painting is 30 rupees per meter square. For 1 meter square, the cost is rupees 30. So the total cost will be how much? Total cost will be 225 into 30. We get 13,000. Okay? Now, the case is finding the total cost 225 into 30 will give us 6750 rupees only. But the question is about to paint the both sides, front side also, back side also. So 6750 rupees for front side, 6750 rupees for the back side. Together cost is 13,500 rupees. Okay, na? Now a rhombus having diagonals 16 centimeter and 10 centimeter. Find its area. What will be the area of that diagonal? Tell me.
Perimeter.
Area, not perimeter. You have to find the area of that rhombus.
If they will give perimeter, I need to perimeter.
Perimeter is different. First of all, you have to find the area.
After that, you find perimeter.
800.
800. Answer 80. Check. Okay. Area of rhombus. Area of rhombus, we will know that it is half into product of diagonal. Okay, half into product of diagonal. So half into one diagonal is 16 and one diagonal is 10. Okay, 2 will cut 16 8 times. 8 into 10 we will get 80 centimeter square. So the area of the rhombus whose diagonal is 16 centimeter and 10 centimeter is 80 centimeter square. 2 will cut 10 also, then 16 will not cut. Only one it will cut at a time. Na? Here I cut 16 from 2. So if I will cut 10 from 2, I will not cut 16. Understand? Suppose half into 16 into 10. So what I will do? I will cut 10. 2 5 the 10. Now 16 5 the. Okay. So in the next class we will solve more questions based on that. In meantime, you will revise the formulas and the derivation of the each formulas of the different types of quadrilateral. Okay.